So here in example 5, we got this a little bit unusual. We got absolute value of x cubed minus x. Now, if the absolute values were not there, we would know just what to do with this. It'd just be power rule. Well, remember what absolute value means. Absolute value of x is just x if x is greater than 0 or greater than equal. And it's negative x if x is less than 0. So we got something negative, changes it to a positive. Well, what about this expression? Then absolute value of x cubed minus x is just going to equal what's inside the absolute values, x cubed minus x, if x cubed minus x is greater than or equal to 0. And it'll equal the negative of what's inside. Instead of negative x, it'll be negative of x cubed minus x if what's inside the absolute value, the x cubed minus x, is less than 0. So we need to find out where this thing's positive and negative. Well, first let's find out where it equals 0. So x cubed minus x is equal 0. Set that equals 0. Got a common x we can factor out. X squared's left in the first term and a negative 1 in the second term. So either x is equal to 0 or x squared minus 1 is equal to 0, in which case x squared equals 1, adding 1 to both sides, and taking square roots, x would be plus or minus 1. So let's just do a sign chart here. Marking off those cutoffs, 0, 1, and negative 1. And we'll just use test numbers here and find out when this function's positive or negative. So down below here is going to be our product, x cubed minus x. Up above here, we've got two factors. We've got the x and the x squared minus 1. And then we'll pick test numbers in each region. So it's kind of like doing a sign chart for f prime, except we're doing a sign chart for the actual function. So test numbers, let's use negative 2, negative 0.5, 0.5, and positive 2. So if you plug those in for x, we get negative, negative, positive, positive. For x squared minus 1, well, negative 2, whole thing squared is 4 minus 1, that's 3, positive. Negative 0.5 in here, squared is positive 0.25 minus 1, that's negative. Put in a 0.25, you get the same thing, negative. Plug in a 2, 2 squared minus 1, positive. And then this down here is just the product of those two. So opposite signs negative, same sign positive, opposite negative, same sign positive. So this function is negative if you're below negative 1 and between 0 and 1. Otherwise, it's positive. So what we want to do is take this integral, starts at negative 1 right here, break it up at 0 and 1 also. So this will equal the integral negative 1 to 0 of absolute x cubed minus x plus integral 0 to 1 absolute x cubed minus x plus integral 1 to 2 absolute x cubed minus x. And remember, this is true. This is just additivity of areas. So the area under this function from negative 1 to 2 is the area from negative 1 to 0 plus the area from 0 to 1 plus the area from 1 to 2. So why do we break it up like this? Well, between negative 1 and 0, that's in this range here, our function's positive. So that's this case here, you can just drop the absolute values. So in the next step, this will be integral negative 1 to 0, x cubed minus x dx. And here between 0 and 1, that's in this range, function's negative. So if x cubed minus x is less than 0, the absolute value gets replaced with a negative sign. So this would be integral 0 to 1, negative of x cubed minus x. And then plus integral 1 to 2. And between 1 and 2, so that's in this range. And function's positive, so that's this case again. Just drop your absolute value. So x cubed minus x dx. And now, this is just power rule. We know how to finish up there. Just raise the exponent, divide by the new exponent, plug in your limits of integration.